Right, it blue screened on me for some reason. Um, about internet banking. Interesting. Oh, well, I missed the T. What was I looking for? 2D tutorial. Right, I got a blue screen. Don't know what happened there. That's the second blue screen I've had this week, which worries me a little bit. Because it's a relatively new PC. Um, and I better check the audio quality before I go any further. How can I do that? No, I think it should be alright. I better do a quick check. Otherwise, I'll record this video for nothing. So, the problem is how to test the audio, because if you have it on the, if I have it as I'm speaking, I get a nice feedback loop. I don't know, I suppose I should test it. Let's try it. What's happening? Should you just stop? Oh no, I've just lost all my. What's happening? I've lost all my. Oh, I just pressed stop accidentally. Okay. Right. Right. So I'm probably going to get a bit of a weed reverb here. Right. So I'm probably going to get a bit of a weed reverb here. Right. I think that's okay though. Right. I think that's okay though. Right. Hopefully it doesn't crash on me again. Let's carry on. Where was it? We've done that bit. We've done that bit. We've done that bit. We've done that bit. Okay. Ready to end the play. Yeah, we're on the next one, won't we? Oh, I need to start Godot. Oh shit! Have I lost everything that I've done? I don't know where I saved it. I think I pressed save, didn't I? Right. Where was it? Let's see what it remembered. Okay. All right. So it looks like we've lost the animated sprite 2D. Let's just make sure. I think I saved it, but let's just make sure it kept the Windows settings. Yeah, that looks good. That's good. There's an aspect ratio thing and a mode as canvas items. Yeah, that's looking good. All right. Okay. It's not too terrible. I need to figure out why these things are. I'm going to start looking at event viewer if it happens again. Anyway, right. Let's have a look. So, we were. Where did we get to? We did that bit. We did that bit. Okay, so what we were doing is adding a animated sprite. Alright. So this thing requires the. This is a warning because it requires the sprite frames results, which is a list of animations, so we need to create one. Why has it got to download assets? I forget why I did that. Right, is that the sprite frames? Where is that? Oh, under animation, there we go. Under sprite frames. Sorry, the expect time to new sprite frames, there we go. Okay. I'm still not told which sprite frames they are yet, right? Turn sprite frames, you've created turn off the sprite frames panel. Oh, okay, there we go. This is looks like some sprite frames down here. Okay, on the left. Oh wait, did we not do this bit? On the left is a list of animations. Click the default one and rename it to walk. Click animation. I think this is it. I must have missed a step, right? Where's animation? I didn't make it click that animation button. Let's go on this spot. Where's the animation button? Oh, is that it? No. And friends. And friends. File. Where's that animation? Oh, that's good. Then, is that it? That looks like it. There we go. Right, and then we want one for move on up. Find the player images in the file system 10. It just crashed on left on that. So where did my assets go? When I downloaded them, here we go. Now, did I? Where did this come from? So drag the two images from each animation. Then in the art folder you unzipped earlier. Was I supposed to unzip that to particular place? I'm gonna mess up there. I am actually streaming that. Yeah. I think. Yeah. Okay. So I was checking. Maybe I didn't do that right. Did I zip that up into the right place? I'm gonna have to go back on that. I'm gonna have to go that one out. I'm not sure I did the right thing with those assets, but I think I might have to drag them into this particular. I want to I'm trying to follow this to like, you know what? No, I'll just drag that like that. Yeah, screw it. Let's go that way. Yeah, that was easy. I think that's what it. I think that's the step that I missed. So, welcome to here again. So I'm gonna walk, and now we're gonna do it. Is that right? Looks. Oh, that doesn't look like it does have a name. Oh, it's the enemy. That's why. So we're on. Oh yeah. Well, there we go. Okay. So there they are, all the images very good images for each one of them. What we're into the animation. I think the animation image is a bit large, so we need to scale them down so the animated sprite 2D. And into the scale. Some transform, I think. Yeah. It's a 0.5 0.5. So basically, we're reducing this by half. Okay. So do I need to ask what you do one for the walk and the run? Let's say walk and the up. Trigger to corresponding animation. I think that's what I was telling you there. So let's do the other one. So we've got two frames of animation for two different stages. We've got an up, where we're walking up, and we've got a walk, a normal walk, which is that one. So when we're going to be pressing up or down on the cursor key, it's going to be using that. So I don't know if you're going left to right, it would be that one. Okay. Finally, add a. I'm going to save this because I don't trust this not to blue screen. Save scene. That's a bit worrying now. You can't trust your Windows machine not to your main dev machine not to blue screen, like not work dev machine. Finally, add a collision shape 2D as a child of player. So I'm going to right click on that, add child node, collision shape 2D. This will be the thing that determines the hitbox, as it says over there on the right. Now, as you can see, I've got my little player dude there. This will determine the hitbox on the bounds of the collision area. For this character, so the different objects you can use to determine collision areas, like rectangles, capsules, which are like little pills. And for this one, we're going to use capsule shape 2D. I must have to set that somewhere. Okay, there you go, this shape. I don't see it. Oh, there it is. New capsule shape 2D. Right, there we go. So now, I should be able to zoom in. And you can drag using the mouse, middle mouse button. At the minute, you see that little blue thing there? That's my capsule. So the collision detection, if I left it closed, would be there. I don't want that. I want to grab these handles and move this so it encompasses the entire object. So that if anything goes into those particular areas, boom, it will invoke the callbacks that you can respond to in our script. When you finish, your player scene should look like this. Awesome, what a genius arm. It does just that. Okay, cool. Right. Once this is done, the warning that area 2D now will disappear. Yeah, because we now have a shape assigned to it and can interact with the object. Save that scene. Make sure you save the scene. Okay, so we now have the player's animation frame to do. How's it easy right now? We're skipping all this, by the way. These comments sometimes quite a bit of context, but I'm trying not to get too plugged into the weeds. I'm going to ignore them. In this lesson, we're going to have movement, animation, and set it up to detect collision detection. So we have some functionality we can get from it. Now this is the bit where we actually start doing the stuff where it gets interesting, which is writing the script. So click the player node and click attach script. Right click the player node. Let's give it the name of the script. .gd is going to be the file extension for your GDS script. Anything else there? There's inherits, that inherits the same as the player is, so that's the extent part of it. Boom! And if you remember from the last one, we have the virtual functions, which are the way we override existing behavior for our object that we're extending, which in this case is area 2D. And in the last one, we had a function called _init. In the last video that we did, well, the one predating the one that didn't crash. And then we have the _process function, and that gets called every frame with a delta parameter, which indicates to our physics engine and everything else how much time is elapsing for the last time the tick was called, so that the physics and the game runs the same, regardless of whatever the speed of your machine. Our game engines have a delta parameter. Okay. Now, the other thing that's different to what you've noticed before, if you remember, is that it's got these arrow to void type thing. What does that mean? Oh, delta looked different as well. Last time it was just like this. So why is it doing this? Actually, why is it showing me that? That's an error. Oh, right. Why is it showing me? Why is it now changed to this? Well, the reason it's changed to this is an alternative means that you can use in script for specifying the type. The voice type. Type just represents whether it's an integer, a number, a particular complex type, which could be another object or whatever. Now, What we really want to be doing, what we get serious about coding, is using a strongly typed language. And a strongly typed language is just that. It associates well-defined types, such as the floating point number, with the delta. Void, by the way, means I'm not returning anything. If it was one of our custom functions, we can return an int. We could say, well, I'm going to generate a function called custom. I'm going to return it. We are overriding the existing one here, but effectively, GDS will let you do, Godot script will let you do either. I'm just going to roll with whatever it gives us for now. When we do my own game, our own game for the sake of group collaborated effect in our Discord server, I'd like to use strongly typed. There are many reasons for that, which I'm not going to go into too much detail in this video. Right, anyway, but I guess. So in this lesson, we're not playing movement, blah, blah, blah. We've done that bit. Right, so now we've got the script. So now, as you can see, let's just have a look at how this looks in our actual hard drive. Okay, right, so now there's that art directory that I've copied earlier, so there's all our images. And then we have the scene, which we created in the video that crashed previously. And then that's the Godot script. And these are just text files, so you can open it. You can equally open this in anything, so I can open it in Notepad++, for example, or just standard Notepad. And there's the scene, for example. These are just text files, which is one of the reasons I prefer this game on if you don't have Unreal Engine, to be honest. Anyway, so that's how that looks like. I'm not sorry about that now. Well, I'm going to experiment, I think, with upscaling and downscaling from 4K, see if it's feasible. No, not in this video though, but anyway, I like having a nice amount of screen real estate. Alright, so if this is your first time encountering GDScript with scripting language before continuing, it's not, but did I link that in the other video? I think I did. I'm going to grab that link anyway and paste it into our Discord server as we're going along. Right. So, again, I can start by declaring variables. We did a little bit of this last time, but not to the detail that we're going to hear. Or we talked through it anyway. So you remember from the anatomy of the script again as well. So if you remember what this thing is at the top, this always has to be there generally. If you come from an object other than a reference skeleton, and this basically says what this script inherits, what this object. The object that is represented by that script what it inherits from. In our case, this is a player, which is a specialization of an area 2D. But anyway, it does that too when you set that script up. Right. So what we didn't see before, if you remember before, we did something like this. I think what did we have? We had a speed and a what was it? Speed. I can't remember. There's another parameter. I can't remember what was in the script. But in this one, the key difference, we've got this export keyword. And it's going to tell you what it is here. Using export keyword on the first variable allows us to set its value in the inspector. So what this does is it allows these variables to be accessible in here. So if you note here, I can see speed there, but I can't see screen size. But if I make this export here like that, notice how quick it picks up on that. Something you didn't like there, right? Oh, because I'm giving it value. Boom, there you see? That instantly came in. Now that's not what it was asking, but I was just demonstrating what that export thing does. Right, okay, so this is going to be how fast the game moves in pixels per second, and this is going to be the size of the game window. Yeah, so that export basically means it's visible, it's modifiable, mutatable, and visible within this inspector thing here. So that allows us to add as many attributes and properties as we want within there for a particular. I need to get my terminology right. Particular node. I'm seeing. Sorry, seeing. I have to get the terminology. The terminology for me for Godot is new. I'm not an expert on Godot at all. So I'm learning as well as you are in this particular game engine. But anyway, so for a particular scene within here, we can add as many different attributes here as we want. Okay. So if we can adjust the behavior very easily by applying new attributes and properties in here that we can then modify. If we want them to be internal only, we don't put an expert there. If we want them to be external and visible to the inspector, we put an expert. Okay, I've got another line. Right. So your player.gd script should already contain ready and the process function. Ready is called when the node is okay. That's not that. But when the node enters the scene tree. So this is effectively after initialization, because if you remember, this is the underscore init function when the thing is generally created, but this is when it's about to become visible, I think. That's what I'm saying. So it's a good time to find the size of the game window. So we're going to call a function to get that screen size. So here we are setting that internal variable, which is going to relate to reliable. Now, we know, if you remember in the last video, we set these things up in project settings. There. Screen size, so it's a rect. So this is going to be a 2D vector because it has width and a height property, I think. Alright. So we can now use process functions to define what the player will do. This is called every frame, we know this. And we use this to update the elements of the game. So for the player, we need to check for input and press it up, down, left, right. And then move in the given direction and play what animation is appropriate. So first we want to check for input. And we're going to use Waster, I think, in this one. So what we do in Godot engine is we define an input map. So, and we can do that from project settings, or open input map on the top. Oh, where there it is, right. It's not quite big enough. Let's Alright, so we're going to add a new action here. Why I can't add a new action there? Why can't I add a new action? Oh, I need to get a name first. Alright, I see. So this is going to be the move right action. And then we click the plus. And I think I can just press a key here, right? Listening for input. What is that? Oh, it's listening from now. Oh. I missed that. Right, so I'm going to do what we're going to use Waster, right? Press the right key. Oh no, we're going to use the cursor key. Alright, for whatever it is. It could be Waster, but anyway, I'm doing that. So the move right is now associated with the right for key. I assume I need to do that for down, left, right. Alright, so we have another one. So we're going to have move left. Time. So move left. Listen for input. Okay, press left on the keyboard. Send for up. Yeah. Alright. So save all saves and the save the project itself. I'm very paranoid since it crashed a bit, not saving properly. Because I said save all saves or save what saves the project, because that's the Godot file. It's not too onerous because it's not a massively complicated project to reproduce things. Okay, so let me double check that again. So project settings, input map. I've got right, left, up, down. Okay, that looks good. Input map should be like this. Click the close button. What's the state zone? Okay, close. You're only map 1, you can do joystick buttons, mouse buttons. I'd like to look at joystick buttons when we come to the game. Our little project. Okay, so we can detect whether a key is pressed by using input is action pressed, and then you give it a name. So let's grab that and input all this kind of stuff down here. So here's a bit of script. And what's this doing? This is saying, right, okay, we're going to have a velocity which indicates 0 in either direction. So this is a 2D vector, so there's an x and a y component to it. We're going to set it initially to 0, 0. And then we're going to say, right, well, if I'm moving right, I'm going to add 1 to the x coordinate. If I'm moving left, I'm going to add -1. Minus equals, remember from last time you haven't seen that terminology, that's the same as plus equals is the same velocity.x equals velocity.x plus 1. So then effectively we can do the same for each of the different coordinates. So we're setting a vector based on whatever our input is. Okay, what else did it do at the bottom of that? Now what we're saying is if this vector has a length to it, if this vector has a length to it, we play the animated sprite. Okay, I was going to say don't worry about that dollar thing, so we'll come on to it. She's just about to come on to it. See that dollar thing there? So, I was saying, if we have a vector, in other words, if something's being pressed, that's effectively the same thing, we set the velocity associated with this animated, with this object, the player object, which is the area 2D, after normalizing that vector. Now that's important, and it's to do with correcting the speed, because if you move diagonally, you will end up moving faster otherwise. So it normalizes that vector. If you want information on that, there's a nice little video that one of my chaps on our Godot God at the moment sent on our Discord server. Right, okay, so we normalise that to get the velocity, and then we play the animation. Okay, so okay, I don't know why I just reading this as it goes through, because it's just explaining exactly what I did. So we start with, let's set velocity 0, 0, so it's not moving, and then we check for input each time, and add and subtract the velocity for the top 10 direction. So you're all writing down at the same time, so it's in vector 1, 1. Okay. Right, yeah. In this case, we're having horizontal and vertical player. We move faster diagonally. So we're doing that by normalizing it. If you never use vector map for any refresher, you see an explanation of that on the vector map. I think I'm going to go through that again myself to refresh myself too. And I'll paste a link to that into the Discord channel. Brings back memories when I listen to music. Anyway, right, okay, so as we check the player's movie, so we can call player stop on the animated sprite 2D. There we go. So here's the dollar aspect. So that dollar represents, is the shorthand for get node. So It's the shorthand for doing that. In fact, I'll prove that to you by it not actually showing you there. It's one of those is redundant. Oh, by the way, if you want to do comments, make sure you put a hash. I haven't done Python for a number of years. I think that's the same as Python. I'm not sure. Most languages do that. I don't know why. I don't know why this one wants to be different. Or Python wants to be different. If it's just basically something from Python. But anyway, it doesn't really matter there. So yeah, so as I was saying, those two are functionally equivalent. I like the fact that you've got nice intelligence and it tells you when your errors are, well, reasonable intelligence, it tells you when your errors are wrong. You've got it straight away. If I mess up, you very quickly tell. That's not always the case. In this language, to deal with the fact that it's using dynamic typing if you're not using static. I don't want to go into that. I don't really want to talk about that. Let's leave that for another video. Alright. Key descriptor tells another relative path, blah blah blah. Okay, so it's not really that. That's a good point. So it's a shorthand version. Now we've got movement direction, we can update the player's position. We can use trap to prevent it leaving the screen, that's quite nice. So we've got this thing here. Okay. Oh, of course, velocity was that. I misread that here. Velocity is a local variable. What we've done now is done nothing to change anything other than inside this function change that variable. What we need to be doing is associate it with a variable that's associated with the player. So that's what this bit's going to do. Why are we doing that? Are we doing that? Why is it working? Now that we have the moving direction, we don't need the player's position. We can also use clamping to prevent it leaving the screen. Clamping a volume is restricting it to a given range. Yep. And the fly to the bottom of the process function. Okay. Well, that's an interesting thing that's probably worth pointing out as well, especially if you're into programming. Programming is particular, actually, because all languages do it differently. But that is different to that. Very different. And the reason being is that obviously you have if statements and else statements. And what happens in the branch of this particular if is based on the indentation. So effectively putting that there, making them like that, would mean that if velocity is bigger than 1, it wouldn't do it. Which is why we need to make sure, which is why it makes it very obvious. Well, very as clarity to it, make sure it's not indented under else. So indentation is very important to know as it is in Python. It indicates branches and flow. I love this tune. It's one of the best tune out of the Final Fantasy. Right. Okay, that we covered. Delta parameter process. Function returns the frame length. At the time that the previous frame took to complete, using this value ensures that your movement will remain consistent even if frame rate changes. Right, okay, so we've got something we can run now. So we're going to click the run save, click and save. Let me show it's saved. No minute 6 being never defined. No, I thought it was going to tell me something there, but that's a different thing. It's asking me to select the main scene. Well, we will select this one now. This is which scene you want to be running effectively, because we're going to have multiple scenes. Now I can move a little dude around. And I'm clamped, so I can't go off the screen. So that, if you go into that, this basically saying clamp, as in don't allow the value of that position to be anything outside of the ranges of vector.0 and the screen size which we grabbed when we initialized to the size of the viewport. So that means that we can't move off screen. This is the perfect gameplay music for it as well. Just need some Spanish to fight. Right, I'm going to cut this video short here actually and do a little bit later. Now, what you haven't noticed as well, I'll finish it here because we need to do the animation. I'm not going to cut it yet just yet. Because what you haven't noticed is it's the same frame of animation when I'm moving up, down, left, right. But we had a frame of animation for using when we're going up or down. We ain't using it, are we? So, like, we want to be using that one, but we're not. So I think that's what it's going to do next. So let's finish this particular page. Alright. So now that we can move, we need to change the animation that's playing based on direction. So we have a walk, which shows you walking to the right, and the animation should be flipped. The animation should be flipped horizontally using the flip H property for left movement. We also have the up animation. Yes, oh that's right, yes. So obviously when we're walking left, we want this to be flipped so that the little eye is pointing to the left there. So obviously when we come to our football game, that's going to be much more obvious. Okay. So we also have the up animation, which should be flipped vertically with flip V. So we've got flip horizontal and flip vertical. Okay, and it's just a function it's a boolean that we can call. Look at it there. We have the up animation, which should be flipped vertically downward. Let's put this at the end of the process. Okay. So we've already set the position at that point, and now we're going to go. Actually, we just broke it. I don't know why. What's that saying? I didn't paste that properly. Anyway, so yeah, we have to be careful about the indentation. So basically, if the X position is not 0, in other words, if the person is pressing left or right, we're going to use the walk animation. So that there is a reference in that name there, and we're saying we're not flipping vertically. We need to make sure that's disabled in case in the previous frame that was set to true. We're going to be flipping horizontally, in other words, walking right to left rather than left to right, if X is less than 0 from our input vector. And then similarly, if the Y, otherwise, so if X isn't being pressed, so we default to using the walk animation effects press. So if you're pressing X and Y, if you're pressing up and left, you're only going to see the walk animation. If you're pressing down and left, you're going to see down and left or down and right, you're going to see the walk animation because this is on an else if. So this says if not equal to 0. Otherwise, we're going to say is the Y coordinate not 0. In which case we're going to use the animation up. So that up there references that animation, and we're going to flip the vertical. In other words, the Y is going to be pointing down if Y is more than 0. Sorry. So in other words, if you're pushing down. All right. Anyway, okay. Non-Napoleon assignments, let's say that. Non-Napoleon assignments are a common shorthand for programmers since we're doing a comparison test. Oh, okay, yeah. So this is, I think it's talking about that. We could put that into another boolean and then assign that to that, but basically that's it. It's like having an extended for any other screen. Alright. But let's go into that. Anyway. Oh, yeah. That makes sense. Play the scene again. mistake here is to type in the animation wrong. Oh, okay, so this needs to be, this is case sensitive. So we've got the lowercase there, uppercase there. Alright, so that will break it because I don't have an uppercase to view there. And it ain't going to tell you either, you'll only find out when you run it. Alright. Okay, when you show the movement it's working, well we're not, let's run it. Now what I should see now when I move them around, there you go. So moving to the left, you see how the eye is pointing to the eyes, changing direction, left and right. Just keep recording reference. So velocity x is not equal to 0. We make sure the animation walk. We make sure the vector, we're not flipping the vector, flipping the vertical dimension for the animation. And we're flipping on the horizontal based on whether we're moving left or right. And similarly, we now just do 2 frames of animation and we're changing the animation based on the golden. Right. One more thing you wanted us to do. Oh no, a couple more things you wanted us to do. When you're sure the movie is working, you can add this to ready for the player to see it when the game starts. Okay. Hi. Okay. So the color has actually gone high there. Right. Collision. We want players to detect when it's hit by an enemy, but we haven't made any enemies yet. That's okay. We're going to use the signal functionality to make it work. Oh, I don't think we did this in the didn't mention these in the last video. So it's okay. We'll go through them as we are, as we need to. After following the top of the script, if you use the script after right, this defines a custom signal hit that will have our player emit, send out when it collides with an enemy. So yeah, so signals are effectively your way of declaring something externally is going to happen. It's an event. You can trigger that event from within your code and something can react to it. So you say, okay, I'm going to have a signal. I could equally call it, you hit me. It doesn't matter what it calls. We can call it whatever you want. That's our name. Well, simply what it's doing there. But effectively, we're going to emit that signal when something hits us and then something can react to that. Okay, so now is where we come to this node tab here, and this is where our signals are. Yes. Signal hit defines a custom signal which have select the player node and click the node tab to the expectancy list of signals. Where's our player hit signal? Oh! There you go. So, yeah, it needs to be on that thing there. Right, there you go. So that's going to be a custom signal. Notice our custom hit signal is there as well. Since our enemies are going to be rigid body 2D nodes, we want body entered body 2D signal. This signal should be emitted when the body contacts the player. So we're going to connect signals now. So I'm going to right click, connect. This signal will be emitted when the body contacts. So, okay, the game engine is going to call this signal, it's going to emit this signal when something hits, when a rigid body hits and enters our collision shape. I think we created earlier. Okay. This is going to create a function. Okay, so what this is doing is generating a function that gets called as a result of this signal being emitted. So now in our script, so I'm running out of space here. Now in our script, you can see we've got a new function. It creates a function exact name. We don't need to change the defaults right now. Okay. Note the green icon indicates the signal is connected to this function. Okay, that thing there. Oh, we can click on it as well. It tells us what's connected to it. This does not mean the function exists, only that the signal will attempt to connect the function that name. So double click the spelling of the function. And double check that the spelling of the function matches exactly. Now I just can't. Alright. So when this signal is emitted on body entered, we're going to hide the player. We're going to emit our new signal, hit, and then we're going to do whatever this is. What's that? Must be deferred. Okay, this is effectively this is to do with timings of the engine. So I'm going to get too bogged in the weeds there, but effectively this is saying this is disabling the objects that are responsible for collision, but we can't do it just at this point in time. We have to defer that. So I'm going to get too bogged down the weeds there. This time the enemy hits the player, the signal is going to be emitted, and we need to disable the enemy's collision so we don't trigger it more than once. That's what that's about. But we're doing it in a certain way to do the damage and the physics of the damage. Oh, there you go. Disabling the collision can cause negative impact in the middle of the engine's collision. Just a nuance of the engine. Alright. The last piece is another function we can call to reset the player when starting again. Alright, let's have that. Now, that function is currently nothing calling that. If you remember what we discussed about the functions by convention, you have an underscore. This one doesn't. Where should I put it? It's called style. It's been in the top. Nothing's calling this yet, but we're preparing this ready for the next part of the tutorial, which will call that to get the ball rolling. And one thing that we're doing within here is taking a position and setting our initial position to whatever's calling there. We're showing the sprite, we're showing it next to the player, and then we are making sure that the collision is enabled again, which conversely is by saying disabled to false. Really, that's inverse language. It should be saying enabled to true, in my opinion, but that's how we designed it. Alright, let's just, before we close that off, let's just make sure it's still working. And it's not, why isn't it? Oh yeah, because we put that on anyway. Okay, let's do that now. Okay. Right, so I put that back at this and it's ready for the next one. Alright, with the player working on the enemy in the next session. Preston. Okay. I'll do after this video. I'm crazy about we can be watching it anyway, but I'm going to be putting these onto the channel. This is on our Discord server. Link available in the description thing somewhere. Alright, close the screen, sorry.